Okay, so would you get to page 129? Okay. There was a quiz on this past Friday. I didn't get it all done. I'm sorry. I'm done with the very first page. Got that done this morning. I meant to get it done on Friday. Of course, about 2 million things came up. Maybe not 2 million. Might have been only a million. But I'll get it. I should have them in the grade book by the end of today. If you weren't here, make sure you get it in. Once the grades are posted, if you're not real happy with your score, you're welcome to come see me and earn half your points back. Okay, cool. All right, so this week, this is what we have planned. Today is Monday. Tomorrow's Tuesday. All right. Okay, so our chapter tests in this class will be over 2 days. But hey there. But we have to realize that Monday, Tuesday, Wednesday, I'm dedicating solely for going over the reviews, make sure when we're good with the reviews, make sure you have any information that you need for your full sheet of paper, because on the tests I will allow you to use a full sheet of paper front and back. I'm so jealous. Hey there. Lots of came or you guys got the same ride, a whole bunch of people just came out. Traffic suck out there. Yeah. All right, so again, I don't have our quizzes done. I'll get them in the grade book probably by 7th period today. And again, if you don't like the score that you got, or you just want to keep pushing your score up, come see me. We'll go over what you missed, and I'll give you half your points back. Cool? But if you want to come in and do that, you have to come see me 4th, 6th, 7th, or 8th, please. Okay, because those are my off periods. I bet you a nickel we share at least one of those. Maybe. Does anybody not have any of those periods off? Get the one kid. Okay. So my friends, I am on page 129. And I just kind of want to go through this step by step, make sure we feel comfortable with it. I need my thing because we have to go to decimals. All right. That first problem on page 129 says an Uber driver keeps records of the lengths of time each of his rides takes. A partial set is provided. Okay. So because it's a partial set, do we use Desmos or is that like a summary? What you think? Wrong answers are welcome. Go for Desmos, yeah. The only time you're not going to use Desmos is when they give you a 5-number summary. Sound good? All right. Oh, Firefox is installing updates. Like, I just used Firefox. Me complaining about it makes it go faster. All right, so we need to make sure that you feel comfortable on Desmos. Again, I'm using my computer. You're always welcome to use your computer, and some of you are using your phones and some of your screens on your phones. How in the heck can you see anything on there? Because it looks like you smashed it with a hammer. But just going with that. All right, so I want to plug data in on Desmos. So should I go like capital L equals square bracket? Or was there a different way? Yeah, we're going to go plus and then table. Any willing individuals willing to read me across the data? Eight, 10, 6, 16, 10, 14, 45, 21, 21, 11, 15, 8, 20, 19, 14, 28, 75, 18, 20, 16, 10, 9, 22, 16, and 24. Thank you. All right, so we have our data here plugged in just from the list. Everyone, I hope, feels comfortable plugging this kind of information in. Every now and then, I'll come and someone asks how to do something on Desmos. It's like, well, what do I put in for Y? I put nothing in for Y. I'm just putting X data in. Okay. Then it says, make a modified box plot of this data, label the axes completely. Okay. So I'm going to come down here. I can either type in box plot, and it's going to be X shift 1. And I don't want the outliers to show up. Let me make this a darker image. So if I take a look at my data, what is that out here? What's your best guess what that would be called? What is that piece of data called? It's an outlier. Okay. And because on our box plot, we want to exclude any outliers, that means Desmos is already doing Q2 plus IQR times 1.5. Okay. If we don't include it, then we just get this long graph. Okay, and there might be another outlier in there too, because that line looked like one. Oh, what is that one? Looks like we got a couple outliers on here. Is there any more? Looks like 2 of them. Is there more? Is there anything in the hundreds? No. So we definitely have 2 outliers on our data. Okay, again, Desmos tells us. Basically, what it says, if you were to make a box plot, well, make that box plot. Realize, you know, how your box plot is counting on here. I look like it's going 0, 20, 40, 60. So make your best guess what everything would be. And of course, when you look at this, make sure you know this to take place. If I had that data and I conveyed it on here, bless you. If I were just to transpose it, looks like 20%. Let's see, we're going by what? 5? So that's like at 6. Come on. It looks like it's at 10 and 16. $21 and 28 maybe. And then outliers are where 75. So our other outlier, 45. Okay, so right there you would have that problem done. You're just copying what you have on your screen to your sheet, trying to make your scale. Okay, sometimes it's harder to see our minimum. You know, you're making a guesstimate at your minimum and stuff like that, but I'm going to show you how to convey this a little bit better. Okay, and that is a max, which is an outlier. Okay. Then number 2 says create a different but appropriate display for this data. Provide all the necessary marks. Okay, but before I do that, let me go back to Desmos. And let's make sure we know how to put this information in. So if you come down here and you type in stats x_1, that's going to give us our min, Q1, median, Q3, and max. So you could incorporate that into your graph. This did not ask for anything else. I mean, we could do the mean of x1, but it's not necessary on this problem. But I mean, there's different things that we could definitely plug into Desmos. Okay. Now, when it says for problem number 2 to create a different diagram based on our data, what do you think that means? We already did box and whiskers. What's another thing that we would know how to do? Actually, I'm not going to do that. I want to do better than that. All right, so at 8 I have a dot, at 10 I have a dot, at 6 I have a dot, at 16 I have a dot, at 10 I have a second dot, 14 I have a dot, at 45 I have a dot, 21 I have a dot, 11 I have a dot, 8, we have 8 already, we did second dot, 20, 19, 14, we already added 14, right? Yep. 28, 75, 18, already had an 18, right? No, we didn't. 20, 16, 10, 9, 22, 16, and 24. Okay, so it's a dot plot. Is this an ideal dot plot? I mean, can we see a little bit of a shape to it? Yeah, there's definitely shape to it. There's other ways that we could have gone through this that might make it a little nicer. We might have said values from 0 to 5, zeros from 5 to 10, 10 to 15, 15 to 20. Might give us a little bit better look. Hey. Okay, so what's the right way to look at the data? Both. Okay, and again, we're on page 129. We're reviewing for the test that we'll have. We have a 2-part test on Thursday and Friday of this week, so review, review, and review. And again, because it's a test, you can use a full sheet front and back piece of paper. All right, is there anything so far that we've done? So that's problem number 2. Problem number 3. Give me a description of what this data looks like. Skew right. I like it. So remember, if we say skew right also means skew positive. Okay, just in case I have a choice on something being skew positive on a multiple choice, you'll realize positive and right means the same thing. Okay. All right. We good on 1, 2, 3? On problem number 4, says use the set below for the following question. The number of traffic accidents by section of town in August of 2016. So center downtown 112, the south side's 46, west side's 36, north side's 35, east side 30. So what display would work wonderful for this information? Center 112, south 46, west 36, north 35, east 30. What do you think? Stem plot? Let's see, if we did a stem plot, so you know, like stem and leaf type of thing? Yeah. We could, but why I don't like that is we have categories based on our accidents. Does that make sense? Yeah. What do you think? I think a pie chart or a circle graph would work really well. Unfortunately, we have to do something to our data in order to make it right, because our circle or pie chart needs what? Percents. Thank you. So we want to, I think a pie chart is going to work. We need to find the percents. Okay. So someone have a calculator out? Or a phone? Will you add those up for me, please? Who in the heck is texting me? My phone is blowing up. Oh, it's the doctors who are speaking next week. What's that? 259. Thank you. All right. Would you go 112 divided by 259 and then move the decimal, give me a percent? 43%. Cool. And then 46 divided by 259 is? Yeah, we'll go 17.7. That's fine. 36 divided by 259? Okay. And then 35 divided by 259? Okay. And then 30 divided by 259? 11.5. Okay. Now, if we wanted to get totally perfect, if we had 43, 17.7, 13.8, 13.5, and 11.5, this should add up to 100%. But I know that we're going to be off a little bit. Why are we off? We might have rounded up when we could have rounded down, vice versa. But for the most part, this problem will work just fine. All right, so let's make our pie chart. Let's go better than that. Just because I can. Okay. Got myself a circle. So 43% is just a little bit less than half of the circle. So that's the central. And then, let's see, 17.7%. This is the south part, so 17.7%. And then we're just going to kind of break it down from there. So we could do the west at 13.8. We could do the north at 13.5. And we could do the east at 11.5. So there's a nice representation of our data. I'm on page something. So looking at the pie chart, is it perfect? No. You certainly could have nicer pieces of, do it on a computer. It's going to come out nicer too, but it looks good. Which display would be appropriate to represent this data visually? Explain your choice. Explain why a histogram would not work here. Why would a histogram not work here? Well, let's go back in our book, into our notes. Looked at where is histogram. Bar chart. Histogram on page 7. Let's see. A histogram is one of many data displays for quantitative variables. It consists of bars of equal width that represent a range of values along one axis. The height of each bar corresponds with the raw count or percentage of observations that have occurred in the width. A well-constructed histogram is presented below on page 7. Let's see, how many bars should we have? I know that there was something about histogram that it said. Okay, histograms have an advantage of being able to display huge data. Let's see. So a histogram, I think what they might have been trying to aim us on this, they might have wanted to have us make a bar chart. And you remember a bar chart would have been like this. Okay, where we would add centers, W, north, and east. They might have wanted to do this with a bar chart rather than the pie chart. But then the histogram, because we have categories, the categories won't work. Okay, if I use the bar graph, the categories would work. I also like the pie chart, so I'm giving you two different things to go with on that. Okay. All right. So I'm going to pause there for a minute. So it says, from the data set of points, is on page 130, scored by the Hayes High School basketball team below, answer each question. Find the mean, find the median, find the standard deviation, find the IQR, find the range, find Q3, lower boundary, upper boundary. Oh, okay, cool. We have all kinds of information here. So what can we use for this data? Does Desmos work? And why does it work? You're absolutely right. Oh, so good. I couldn't answer it any better myself. Good job. All right. It's not a 5-number summary, so it's not going to help us. All right. So, whoa, dude, come back. All right, this basketball team, help me out. I got 46. I got 38. Keep me going, somebody. 40. 54. 72. 50. 46. 39. 39,
48,
48,
33,
33,
40,
40,
26,
26,
50,
50,
61,
61,
47,
47,
40,
40,
51,
51,
40,
40,
55,
55,
62,
62,
39,
39,
34,
34,
44,
44,
and 46.
and 46. All right. So they want us to find the mean, yes? Oh, geez. So if we find the mean, we could do mean, type in just the word mean, and then x underscore 1. So we have a mean of 45.875. $45.875. If we wanted to find the median, we might be able to get away with this. Let's see if it works. Median. Yes, median will work. So it says the median is 46. Find the standard deviation. So standard deviations is div. So standard deviation is going to be 10.2. Find the IQR, so then we can go down here and we just do stats of x1. So the IQR is going to be 50 minus 39.5. So the IQR is going to be 10. Find the range, 72 minus 26. What's 72 subtract 26? 46. Sweet. Find Q3, 50.5. And then we have to find Q1 is 39.5, 39.5. And then we have to figure out outliers. So in order to find the upper outlier, what was the equation? Thank you. And then lower was? Perfect. Thank you. All right, so Q3 we have is 50.5 plus 1.5, and I said the IQR was 10. So 50.5 plus 15 is going to be 65.5. That's our upper outlier region. And then Q1 we saw was 39.5 minus 1.5 times the IQR, which is 10. So 39.5 minus 15, 24.5. So we have our upper bound and lower. Cool. Upper bound 65.5, lower bound 24.5. Did I do my math right? Oh shoot. 24.5. Based on the mean and the median, what conclusion can you make? So I have a mean of 45.875 and a median of 46. Is it relatively normal? Does it seem to be skew? What do you think? I think it's pretty close to being normal. Okay, though the mean is dragged down just slightly to the left, it's pretty close. I mean, if you rounded 45.875 up to the next round number, it gets to 46. And then what does the mean measure in the context of this question? The mean is the average amount of points scored by this basketball team. And then what does the IQR measure in the context of this question? The IQR, I have to write this down. So the IQR is 10. And if we look at the median was 46. So basically, we're looking to say from 36 to 56 points, we score most of the time. Something like that. We're not looking in for specifics, but if I were to track your basketball, or if I'd like, oh, I wonder what the score would be, I could say that most of the time you're going to score between 36 and 56, from 36 to 56 points in a game. Okay? So that's kind of what the IQR measures. It's going to be the majority of the time your data should fall within that range. And then explain what Q3 measures in this question. So Q3, we said Q3 was 50.5. We score up to 50.5, 75% of the time. Because remember, Q3 is at the outlier. And then identify any outliers for this data set. 72 is an outlier?
Yeah.
Is there anything else?
No.
So 72 is our outlier. And it would be the upper. Cool. All right, so my friends, we've got page 129, 130 up through number 18. Tomorrow I plan on trying to finish up this review, maybe get a little start on the next review. Wednesday we'll finish up all our reviews, make sure we have our full sheet of paper fully filled out for our two-part test on Thursday and Friday. Yeah. Yeah. But like you could use like the full sheet one day and then like go, man, I have part 2 tomorrow. I need to remember to write down these, it doesn't have to be the same, but it could be the same sheet, but you could add to it later.